Welcome, everyone. I'm excited to be your guide as we explore the Rust programming language. Today marks the 3-year anniversary of our team's journey with Rust, and I'm happy to be leading this tour. On the left side of the slide, you'll see a Rust Playground, which is an online coding environment where we can experiment with Rust code in real time. Let's start by typing in a simple Hello World program. We'll use the println macro to print the message, Hello Woo.
Welcome to the first chapter of our Rust programming journey. We'll be covering the fundamentals such as functions, variables, and basic data types. You'll be introduced to Ferris, the cute crab mascot of the Rust programming language. As you become more familiar with Rust, you can consider yourself a Rustacean, a term used to describe people who use or are interested in Rust. This code demonstrates 2 types of comments in Rust: line comments and block comments. Line comments start with 2 forward slashes and extend to the end of the line. They are commonly used to provide brief explanations or notes within the code. Block comments are surrounded by slash and can span multiple lines. While line comments are generally preferred for brevity, block comments can be useful for temporarily disabling chunks of code during testing or debugging. In Rust, variables are declared using the keyword let. The Rust compiler is intelligent enough to determine the data type of a variable based on the value assigned to it, so you usually don't need to explicitly specify the type. However, if the type cannot be inferred, you can add it to the variable declaration. One interesting feature of Rust is that you can assign a new value to a variable with the same name, a concept known as variable shadowing. This creates a new variable with the same name but a potentially different type without affecting the original variable. It's worth noting that while this feature can be useful in certain situations, it's important to use it with caution to avoid confusion and maintain clarity in your code. Another convention in Rust is that variable names are typically written in snake case, where words are separated by underscores to improve readability. In Rust, variables are immutable by default, meaning that once a value is assigned to a variable, it cannot be changed. To make a variable mutable, you need to use the mut keyword in the variable declaration. This allows you to modify the value of the variable later in your code. It's important to be mindful of the mutability of your variables, as using mutable variables inappropriately can lead to unintended changes in your program and make it harder to reason about the behavior of your code. Rust's emphasis on immutability by default is a key feature that helps to prevent bugs and enhance the reliability of Rust programs. It's a key aspect of Rust's focus on safe and secure programming. You can think of immutable variables as being read-only, while mutable variables are read-write. In summary, this code snippet declares 2 Boolean variables, assigns them initial values, and uses an if statement to print a message based on the value of isActive. Unsigned integers are integers that can represent only non-negative numbers ranging from 0 to a maximum value determined by the number of bits used to store them. Here's some additional information about unsigned integers in Rust. U8 represents a whole number from 0 to 255, stored in 8 bits. U16 represents a whole number from 0 to 65535, stored in 16 bits. U32 represents a whole number from 0 to 42949672995, stored in 32 bits. U64 represents a whole number from 0 to 18446740073, stored in 64 bits. U128 represents a whole number from 0 to 34025, stored in 128 bits. Your examples show how to declare variables of different unsigned integer types and assign them. Unsigned integers are commonly used when working with bitwise operations or when representing numbers that cannot have negative values, such as counts, sizes, or indexes. Here's a summary of signed integers in Rust. Signed integers are integers that can represent both positive and negative whole numbers. Here are the standard signed integer types in Rust. I8 represents a whole number from 128 to 127, stored in 8 bits. I16 represents a whole number from 32768 to 32767, stored in 16 bits. The code example provided declares 3 unsigned integer variables and prints their values to the console. It demonstrates how to declare variables of different unsigned integer types and how to use them in a Rust program. Signed integers are commonly used for arithmetic operations, where negative values are expected, such as temperatures, financial amounts, or when working with large numbers that can be positive or negative. Rust has 2 pointer-sized integer types. Usize, an unsigned integer type that is the same size as a pointer. Isize, a signed integer type that is also the same size as a pointer. These types are commonly used to store indexes or sizes of things in memory, as well as for pointer arithmetic. Here's an example of using usize to iterate over an array. Rust let r u8 10 1 2 3 4 5 6 7 8 9 10 for index in 0 r.len, let value r index. Print array element at index is our index value. Explanation. The variable index is a usize that iterates from 0 to the length of the array, which is a usize value returned by the len method. The index expression uses the usize variable index to access the corresponding element in the array. Let's talk about floating point types in Rust. Rust has two primary floating point types. F32, a single precision floating point type, also known as a float in other programming languages. It uses 32 bits to store a number. F64, a double precision floating point type, also known as a double in other programming languages. It uses 64 bits to store a number. Here's an example of using F32 and F64 in a Rust program. The variables x and y are assigned values of type F32 and F64, respectively, and are used to store the value of pi. The println macro is used to print the values of x and y to the console. While the output shows the same value for x and y, it's worth noting that F64 can represent numbers with more precision than F32. Floating point types are commonly used in scientific computing, graphics, and other applications where precise decimal representation is necessary. Tuple types are a convenient way to package multiple values together into a single compound value, similar to a struct. They're defined by placing the values in parentheses and separating them with commas. Each value in the tuple can be of any type, including other tuples, and the number of values is called the tuple's arity. Tuples are commonly used in Rust to return multiple values from a function or to pass multiple values to a function. They're also useful for temporary storage of multiple values. One thing to note is that tuple types are unnamed, which means that their elements can only be accessed by their index, starting from 0. This is in contrast to structs, which have named elements that can be accessed by name. Arrays are a fundamental data structure in Rust, and they're commonly used to store a fixed number of elements of the same type. Here are some key points to remember. In Rust, arrays are defined using square brackets and a fixed length, like this. Let AR, I32, 5, 1, 2, 3, 4, 5. The length of an array is part of its type, and it must be known at compile time. This means you can't change the length of an array once it's been created. Arrays are passed by value, which means that when you pass an array to a function, a copy of the array is made. You can access the elements of an array using their index, starting at 0. For example, the first element of the array R above can be accessed with arbo. Arrays are useful when you need to store a fixed number of elements of the same type, and when you know the size of the array at compile time. A slice is a view into a range of elements in an array, vector, or other sequence. A slice is not an independent data structure. It's simply a view into an existing collection. Syntax. A slice is defined using square brackets with the name or expression inside. For example, my array 0 would create a slice of the first 5 elements of my array. Properties. Slices have a length, which is the number of elements in the slice. Slices can be empty. Slices are cheap to create and cheap to copy because they don't own the underlying data. They just provide a view into it. Example, Rust. Let ARR 1, 2, 3, 4, 5. Let slice R1. Create a slice of elements 1 through 3 inclusive for I in slice, println, element, I, output, element, 2 element, 3 element, 4, explanation. The variable AR is an array of 5 elements. The slice is created by taking a reference to the elements in the array from index 1 to index 4, inclusive. The for loop iterates over the elements in the slice, printing each one. Notice that the slice doesn't own the underlying data. It just provides a view into it. Slices are a powerful and efficient way to work with sequences of data in Rust, and they're a fundamental part of the language.
A str in Rust is a borrowed string, a view into a sequence of bytes representing a string with a known length at runtime. It's defined as an alias for the type adduate, which is a reference to a slice of bytes. STRs are created using string literals or by slicing an existing string. For example,
Rust let full name John Doe. String literal, a static str. This line declares a variable called full name and assigns it a string literal, which is a static string stored in the read-only memory. The static star indicates that full name is a reference to a str, string slice, with static lifetime, meaning it exists for the entire duration of the program. Rust let first name a full name, slice the first 4 characters. This line creates a new variable called first name and initializes it with a slice of the first 4 characters of full name. The syntax full name zalero creates a slice of the string full name from index 0 to index 4, excluding the character at index 4, Rust println, full name. These lines print the values of full name and first name to the console. The ballots in the format string are placeholders for the variables to be inserted.